We're continuing on reviewing some of our algebraic skills before we go into lesson 413, and this video particularly focuses on the quadratic formula being used to solve quadratics. So you can see that on the top of the screen. Now, one of the most important parts of the quadratic formula is what's inside the square root. The b squared minus 4ac, not the square root itself, just what is inside the square root. That is called the discriminant. That discriminant tells you certain traits and characteristics of the solutions for a quadratic function, a quadratic equation. And we're going to talk about how you can use that to help you. Also, we're going to use some shortcuts. The quadratic formula is introduced in Algebra 1. In Algebra 2, you look at how to solve them for imaginary solutions. And in pre-calculus, well, it's time to master solving quadratics. You know, we can factor, we can complete the square, or we can use the quadratic formula. And so we're going to work on figuring out some shortcuts we can use. Now, for us, keep in mind, you should be able to know what's your A, what's your B, what's your C at this point in pre-calculus. So when I write down the discriminant, and I have b squared minus 4ac, I might as well do some of the math while plugging in. So when I say b squared, negative 3 squared is 9. Why not just write down 9 instead of parentheses, negative 3, parentheses, squared? No, just write down 9. The next part says negative 4ac. Well, maybe I can just do negative 4 times a. Negative 4 times 2 is a negative 8. And then I'll do the last one. And the last one says c. Well, c is 4. So really, this is telling me take 9 and subtract 32. So 9 minus 32 is negative 23. So here's the discriminant. That is what goes inside the radical, the negative 23, which means a negative and a radical, I'm going to have an imaginary solution. I'm going to have two imaginary solutions. But also, if I look at the number 23, that itself is not a perfect square. So I will have to simplify the radical and deal with some things from there. But I know what's going to happen because 23 is prime. So when we go through, now we're going to go to the quadratic formula. X equals, and it says negative b. So why not just make the opposite of b? So if b is negative 3, the opposite's a positive 3. Why write down negative parentheses negative plus or minus the square root? Well, you've already found what goes in the square root. You already found b squared minus 4ac. It's negative 23. So, I'll do it like this. Square root of negative 23 over 2a. Well, a is 2. So why not just write down 4? Well, the only thing I can do, since 23 is prime, is I can take out the negative, make it an I, and leave the 23 inside. And that's my answer. So we're going to use some of our shortcuts here to help us to go faster with the quadratic formula. You don't need to do all the parentheses and squares. A lot of it's up here with your mental calculations. All right, so if I look at number 9, again, same idea, b squared minus 4ac. So I have b is negative 6. Negative 6 squared, 36. Just going to write it down. Minus 4 times a. Well, a is 1, so I have minus 4. Times c. Well, that's 25. So really, that would be 36 minus 100, which in this case is a negative 64. Again, notice you have a negative. Your discriminant is negative, which means you're going to have two imaginary solutions. And by the way, the number 64 itself, that's a perfect square. If I say what's the square root of 64, you should know it's 8. So that means it's going to be easy to simplify the radical if your discriminant is a perfect square. X equals negative b. Well, the negative of a negative 6 is positive, so I'm going to write on this. Plus or minus the square root of your discriminant, which, by the way, is a negative 64. So I might as well just do this. I squared root of 64, just take that out automatically. And then 2a on the bottom, well, a is 1. Why do I need to write down 2 parentheses, 1 parentheses? It's just 2. 2 times 1. Well, in this case, the square root of 64 is 8. So I have 6 plus or minus 8i over 2. Now, both of those are going to be divisible by 2. And so I'm going to do 3 plus or minus 4i. And that's my answer. So, use some of the mental shortcuts for calculating your discriminant. And then look at the number. If it's a perfect square, well, guess what? Your radical, it went away. I mean, square root of 64 is 8. If it's not a perfect square, you're going to have to simplify the radical, which is why we did the first 4 problems. All right, number 10, b squared minus 4ac for the discriminant. So I have b is 5. Well, last was 25. Minus 4 times a, so minus 4 times 3, so minus 12. Times c, which is negative 2. All right, so in this case, 25 plus 24. So that's 49. Interesting. That number is not negative, so there's not going to be an I. And that number is a perfect square, which means when I plug that into the square root, it goes away. So I wonder if my answers are going to be irrational. I mean, the square root should go away. My answers should not be irrational. My answers should be rational. Look what happens. If I say x equals negative b, well, b is 5, so negative 5 plus or minus the square root of 49 over 2a. Well, a is 3, so twice 3 is 6. So x equals negative 5. Well, square root of 49 is 7 plus or minus 7 over 6. Now realize, this is really 2 problems. One of them says negative 5 plus 7 over 6, which is 2/6, which is 1/3. One of them says negative 5 minus 7 over 6, which is negative 12 over 6, which is negative 2. And so those are my answers. They are rational. Now, whenever you get a rational answer, when you do the quadratic formula, that means it was factorable. I could have factored that because I have a discriminant that is a perfect square. I mean, this would factor into 3x minus 1 and x plus 2. And if I were to distribute that out, I would get 3x squared plus 5x minus 2. So if you ever do the quadratic formula and you notice that you get a discriminant that's a perfect square, you could have factored. That's what it tells you. Now, if you get a discriminant that's negative, that means you're going to have imaginary solutions. So that discriminant tells you certain traits. All right, so last one, number 11. I have b squared minus 4ac. b is a negative 4. Well, negative 4 squared is a positive 16. Minus 4a, so minus 4 times negative 2. Well, that's a positive 8. Times c, which is a negative 7. So in this case, 16 minus 56 is negative 40. Again, negative, that tells me I'm going to have 2 imaginary solutions. 40, not a perfect square. So I'm going to have to simplify my radical. So x equals negative b. So the negative of negative 4 is a positive 4 plus or minus. I'm going to pull the negative out right now and do I squared of 40 over 2a. Interesting. A is negative 2, so that's going to be a negative 4 on the bottom. Let's try this out. Well, off to the side, let's simplify the square root of 40. Well, 40 breaks into, again, I do perfect squares. 4 and 10. 4 breaks into 2 and 2. 10 breaks into 2 and 5. So I have a 2 squared. So that comes out and becomes a 2. So I have a 2i. And the 2 and the 5 remain on the inside and become back to the 10. So I have 4 plus or minus 2i over negative 4. Well, let's divide everything out. I like to divide everything by a negative because you should never have a negative in your denominator. That's just wrong. Don't do that. So a positive divided by a negative is a negative. So I took the positive 4 divided by negative 4, and I'm not doing the 4s, I'm just doing the sign. So positive divided by negative is going to be a negative. What about this? Well, positive for the plus or minus divided by a negative is going to be a negative. A negative divided by a negative is going to be a positive. Well, isn't that interesting? It didn't change anything. So that allows me to do this. And then I realize everything here, here, and here, whatever's in the radical is protected, is even. So I can say negative 2 plus or minus I squared of 10 over 2. And that's my final answer. So that one's a little bit weird. When you have a negative at the bottom, just divide out the negative. And all that really did, now technically what it did at this point is when I divided to here, I could write it as a minus sign over a plus sign. Just to show that I divided by a negative. We just always kind of keep it as plus or minus in that sense. But that is a quadratic formula. Notice simplifying radicals is going to fall into place whenever we're doing that. Notice when you have an I, it happens when you have a negative discriminant. And if your discriminant is a perfect square, the square root goes away. So the next video, make sure you have your graphing calculator. We're going to look at how to refresh your memory on how to find zeros using our graphic calculator down below, not Desmos.